Few people know that an ordinary LED bulb can be easily repaired by oneself, and not just repaired, but upgraded to last forever. I've accumulated a few of these LED bulbs, and now I'll show you how to repair it without any special tools, and even without a soldering iron. To disassemble it, you need to separate the diffuser from the lamp body. It's convenient to do this with a knife. Sometimes the reflector is glued, so you need to pry it a little. If you can't open it, you can just place the knife and tap it from above with something. Looks like it's coming off. You can see, right, it's already starting to come apart little by little. Oops! Inside we see 13 powerful LEDs. But what's interesting for us is that usually only one burns out, and it's enough to put a jumper on this LED. And the rest of the LEDs will work because they are connected in series, like links in a chain. That is, if one link breaks, the entire chain is broken. To determine where the non-working LED is located, it's enough to examine them very carefully. The non-working LED usually turns black. And here we see a small dot on this LED. But there is another situation. We open a large lamp. Compare this. There is a regular one and a huge one. The smartest video on YouTube. So, in this lamp, you can see a different circuit is used. There are more LEDs, and they are even numbered. I examined all the LEDs very carefully, and none of them have a black dot. Therefore, another method needs to be used here. You need to carefully press on the LEDs with a toothpick while the lamp is on. And as soon as you press on the non-working LED, it should start working or at least flicker a little. You need to do it carefully to avoid getting shocked and not touch the LEDs, because they might have phase voltage. You should press in the middle, kind of wiggle it slightly. It's better to use protective glasses to avoid being blinded. No, not this one. Okay, let's move on. Reach the 17th. Oh, here's the 12th. Alright, the faulty one is identified. But sometimes, even with these methods, it's not possible to find the faulty LED. Then you need to take the lamp, turn it on, and look in complete darkness. Usually the LEDs barely glow, and only the non-working one will not light up. After the faulty LED is identified, we proceed to repair. The first method is to short it with a very thin wire. That is, to restore the electrical circuit so that electricity bypasses the faulty LED. All the other LEDs will work because the lamp has a special driver that stabilizes the current, and the energy will be evenly distributed among the working LEDs. You can get a thin wire from an old charging cable. Cut it, it doesn't work anyway, so it's not a loss. Oops, I knew it. Mostly there's a bunch of rubber. Look how little actual wire there is. The Chinese saved on materials. That's why it worked so poorly. Let's strip it. And here are the wires, look. This is quite a meticulous, difficult process. It might not work the first time. You need to place it on the LED so that the ends of the wire touch. It won't work the first time. You need to put it on the LED so that the ends of the wire touch these contacts. See, there's the solder over there? Then the current will flow around the burnt out LED. Yes, press the wire against the LED and then twist the end so that it stretches and presses tightly against the contacts. See, the wire went right under the LED. Testing! What did we get? Oh, everything works perfectly. If you look closely, you can see that the LED is not lit. Yes, but we had a hard time with this wire. It's very small and it's difficult to hit it precisely. That's why there's another method to repair this lamp much more easily. You can short the faulty LED with sealant. Few people know that black window sealant conducts electricity. So, we squeeze out a little bit of this sealant. You can do it carefully on a piece of paper. This amount will be enough for us. Then we take a toothpick. Apply it to the LED completely, so it covers its exposed contact, and test it. Oops! Oh, it's blinding, just crazy. Yes, everything is perfect. Super. The lamp is working. The sealant method is very simple. You can literally repair a lamp in a second. I managed to restore all the lamps. They all work. But there's some strange problem with this one. Apparently water got into it. Here's a small Toshiba. The diodes are intact. You can see only one has burned out and something has oxidized between the tracks. Now I'll tell you how you can significantly extend the lifespan of an LED lamp. The main reason LEDs burn out is overheating. It feels like manufacturers deliberately limit the lifespan and set the current on the LEDs so high that they overheat and burn out after the warranty period. In essence, LEDs can last forever if they are provided with a proper thermal regime. The simplest method to cool it during operation is to remove this diffuser. Without it, as practice shows, the temperature of the lamp is much lower. Now we will conduct an experiment. I will turn on this lamp for 5 minutes using a stopwatch and check to what temperature the LEDs themselves heat up. Then the same thing without the diffuser. So 4 minutes, 57 seconds, 58, 59. Done. Exactly 5 minutes. The casing heated up to 37 degrees. We are specifically interested in how much the LEDs on the board have heated up. Quickly measure it before they cool down. 74. In just 5 minutes it heated up so much. This indicates that the LEDs will quickly fail. Now we will turn it on in the same way, but with the cover open. The bulb has cooled down. 33 degrees. We turn on the lamp and the stopwatch for 5 minutes. Well, 5 minutes have passed. We measure the open lamp. 60 degrees. As we can see, the temperature has become much lower. Accordingly, they will last longer. Another interesting point, such a bulb without a diffuser shines much brighter. That is, this diffuser, it turns out, absorbs part of the light. See for yourself. And by the way, without the diffuser, it dazzles even less. You see now until it doesn't even glare. And look how it is with the diffuser. You can ensure even better cooling for the LEDs by drilling many holes in the casing. Let's try to open this bulb and see what's hiding on the other side of the LED board. Oops! What's there? Carefully take it out. There's nothing there, just 2 wires going. The small board is on an aluminum base and it is inserted into an aluminum cup. This cup provides cooling. To improve cooling, we will now drill some holes. By the way, it drills very easily, like through butter. Look at the beauty we're getting. Now air will circulate inside this socket and the LEDs will breathe easier. Well, this is the lovely result we got. Look at what a cool little bell this is. We turn it on and test it. As you can see, it lights up normally. The board fit in there well. Let's start. 5 minutes have passed. So, 56 degrees. As we can see, the temperature has dropped, but not significantly. I think we need to further improve this system and increase the cooling area. For this, we will now screw in the screws from the inside so that they stick out here and dissipate heat even better. Oh. This is what we end up with. The main thing is to press them tightly with pliers to ensure the lamp cools better. For reliability, we will secure these screws with sealant so they don't wobble and maintain good thermal contact. Just take a look at what a beauty it turned out to be. It's like a rocker lamp. Let's check how effectively it will cool down. Let's turn it on. Start. 5 minutes have passed. Accurate to the second. Oops! 50. 52. There is another method to extend the lifespan of this lamp. You need to reduce the current of the LEDs. It's quite simple to do this. In every lamp there is a driver, and near it are current setting resistors. Here they are marked as RS. There are usually 2 of them. You need to take something sharp and carefully scrape off the coating from this resistor. Not all at once, but little by little. At the same time, you need to measure the power through a wattmeter. You need to reduce the power by about 1.5 times. You might not even need to do any cooling. Even with the diffuser, it will work for quite a long time. In short, all these methods work and definitely lower the temperature. The method with screws, of course, turned out to be the most effective. But it's enough to simply remove the diffuser from the lamp, and its lifespan will significantly increase. I've been repairing such bulbs for several years now, and the experience shows that they work perfectly after repair. You can confidently try it. There's nothing complicated about it. So don't rush to throw away old lamps. It's better to preserve the environment, and repair them so they can continue to serve. After all, manufacturers are interested in you buying them as often as possible, spending as much money as possible. But there's no need for that.